Okay, so we come to, this is in problem or session. This is from session 10.2, where we have limit at infinity. Limit at infinity. Okay, limit at infinity is when we have the limit of x going to infinity, either to positive infinity or to negative infinity. So anytime you see that the limit is going to infinity, either positive or negative, then that is what we call limit at infinity. That is what we call limit at infinity. Okay, so anytime you want to get limit at infinity, you must make sure that you write whatever function is given to you in this form. In this form, limit as s goes to either positive or negative infinity. In this form, where p is greater than 0. So we want something to be like the power of the denominator must be greater. If it is so, we know that this limit is 0. We know that that limit is 0. So anytime you are finding limit at infinity, that means limit going to positive or negative infinity, please watch out for this, because when you now take that limit of that, we get 0. So watch out for that. Okay, so in solving each of these, that is what we are going to be watching out for. Okay, because of this property we have mentioned now. Okay, so let's take the first one. So A, we want limit as s goes to infinity, s squared minus 1 over 7 minus 2x plus 8s squared. Okay, so this limit, if you rewrite this, you are going to be getting limit as s goes to infinity, s squared minus 1 over 8s squared minus 2x plus 7. So if you look at this limit, the highest power of x at the numerator is 2, while the highest power of x at the denominator is also 2. So this limit is the same or approximate to this as s minus. Okay, so the limit is approximate to that. It's the same with that, because the behavior of it will be with the highest power of the x that is there. Okay, so with this now, we can now have limit as x goes to infinity. This and this can cancel, then we have 1 over 8. All right, now what will be the limit if we take the limit? There's no more x in the function, so it's a constant one, and the limit of a constant function is constant. So that will be the answer for that one. Okay, let's go to the second one. We have limit as s goes to negative infinity of x over 3x minus 1 square. Okay, so this one we need to open up this and see what it will give us. This will be limit as s goes to, please don't throw away your limit, please carry it along in your calculation. So this becomes 9s squared minus 6x plus 1. Okay, so that will be the expansion of the numerator. Then it will be limit as s goes to negative infinity. Okay, so the behavior will also be with the highest power we have. The highest power at the numerator is just x, while the one at the denominator is this one. Okay, so then we have limit as s goes to negative infinity. This can cancel one of these, then it becomes 1 over 9x. 1 over 9x. Okay, so if we look at this, this is the same thing as 9 or 1 over 9. Limit as s goes to negative infinity 1 over x is the same. Okay, and again, by the time we use the property, because this is now 1 over x, okay, now if you use that property, then we are going to get 1 over this. This becomes 0, so multiply by 0, and then we get 0. So the limit of that is 0. The limit of that is 0. Okay, the last one. So we have limit as s goes to infinity, s5 minus s4 all over s4 minus s3 plus 2. Okay, again, this limit has the same behavior, is approximate or is equal to x going to infinity of x5 all over x4. Okay, which will give us limit of x over 1, which is x. Okay, that is it. Now, by the time you take the limit, then you are going to be getting infinity. So this limit is equals to infinity. So please take note, anytime you are dealing with limit at infinity, you must watch out in order to reduce it so that you can now have that denominator, but sometimes you may not get that property that will make it 0, like in this case, then it will be infinity. All right, please make sure you take note of that.